Hey all, this is section 2.6. We're just taking like little baby steps forward at a time. So this is going to build off of some previous sections. It even mentions it up here. As you can see, it says, so here's the kind of multiplying problems we've been doing, recently. We did a problem like this where you have 3x squared y times 8x to the fourth y to the fifth. But all of this is all being multiplied together. 3 times x squared times y times 8 times x to the fourth times y to the fifth. So you can basically kind of, put certain factors with each other that can actually multiply together. Like, 3 times 8, like you were doing back in second grade. And then x to the second, you can just multiply with x to the fourth. That'll actually simplify. That's where you add those powers, and then y times y to the fifth is y to the sixth, because remember, y technically has an exponent of 1. And then over here, when you see something like this, 5n minus 9 in parentheses, you can't actually do that subtraction, because they're not like terms, but we can multiply negative 4 times that whole bubble by using the distributive property, the negative 4 times both of those two terms in there. So negative 4 times 5n is negative 20n, and then negative 4 times negative 9, a negative times a negative is a positive 36. Okay. And then this right here, same deal, what's in parentheses you can't really do, but what this is saying is we want to do 2x squared times all of that. So once again, it's the distributive property, but maybe a little bit more, advanced with exponents all over the place. But it's still the distributive property, 2x squared times 6x to the fifth. Well, you can do the 2 times the 6 to make 12, and then x squared times x to the fifth would be x to the seventh, and then it's 2x squared times that. That'll be 2x to the fourth, and then 2x squared times negative 7x. That's minus 14x to the third. Okay, because 2 times negative 7 is negative 14, and then the x squared times the x is x to the third. Now, just, again, I don't want to over-analyze this or over-explain it. I don't think this is, because I want to point out that there is something to notice here with 1, 2, and 3. Problem number 1 you could have described as a monomial times a monomial. Remember, monomials are just polynomials that only have a single term. So this is a monomial, that's a monomial. And then in number 2, we could have described it as a monomial times a binomial. Because negative 4, it's a polynomial. I mean, believe it or not, like negative 4 is a polynomial. But you could be more specific and call it a monomial. And then once again, 5n minus 9, it has two terms. So even though 5n minus 9 you could describe as a polynomial overall, calling it a binomial is a little more specific because it's got two terms. It's a two-term binomial. And then number 3, you probably see where I'm going with this. Number 3 you could describe as a monomial times a trinomial. Because 6x to the fifth plus x squared minus 7x, that's 3 terms for a, so a trinomial, a polynomial. But, notice as we kind of transition into these new kinds of problems that we're going to do, just 4 examples. It was always up here, it was always like a monomial times something else. And in the case of like number 2 and number 3, you had to distribute that monomial through the bubble. Okay? Notice down here, here's the big intro, the big segue, right? The next step for us is doing problems like this, where we simplify, you know? Now, if you notice, this is like a quantity enclosed in parentheses, you know, so it's like this binomial, just polynomial, times this other binomial. How do we do that? You know, it's like this entire binomial times this entire binomial, right? Like there's technically multiplication right there. So what do we do? Well, think of it this way. And again, you might know where I'm going with this because you've had experience, but, you know, here's what I kind of say about it. So think of it this way. Up here, you know, there was only one term that was being multiplied to this bubble. Here, down here, it's like, in a way, we have both of these terms that's being multiplied to this, and so we have to distribute both of them. The 2x needs to be distributed, and the 5 needs to be distributed. A lot of textbooks and teachers, a very high percentage of teachers across this country and maybe even the world, you know, call this FOIL. Because what it really is, it's like an acronym where F stands for something and the O stands for something, I and L stand for something, and it kind of summarizes all of this distributing, you know. When we multiply 2x to the negative 3, that's the F, because the F stands for firsts. 2x and x are the first term in their own bubbles, okay? And then when you multiply 2x, oh, wait, I totally messed that up. Oh my gosh, what an idiot I was here. I hope you caught that, because wow, that was bad. 2x times x, those are the firsts. 2x and x are the first terms in each bubble. But 2x and negative 3, that's what you would do next, okay? That's the O, and the O stands for the outer. Because you see how like 2x and negative 3 are kind of like on the outside of the whole thing? So they're the outers. And then you would move on to distributing the 5. And when you do 5 times x, that's the I. Okay? That's the inner terms. Like, you see how they're like on the more inner ones? And then 5 times negative 3, that's the L. The L here in FOIL stands for the last. 5 and negative 3 are the last term in their own respective bubbles. But again, FOIL applies to this perfectly, but all it really is you got both of these terms being multiplied to that bubble. You have to distribute both of them. So 2x times x is 2x squared. 2x times x. The x times the x is x squared. 2x times negative 3, that's your next term, separate terms. All of these multiplications are like separate terms, okay? So 2x times negative 3 is negative 6x, and then we move on to distributing the 5. 5 times x, well, that's just 5x. What can you do? And then positive 5 times negative 3 is negative 15. So that's all the distributing, and then the only thing left over is I hope here that you see that these two terms here are like terms and they can be combined. Negative 6x plus 5x, that combines to be negative 1x. Negative 1x, or just negative x. So the 2x squared comes down, that couldn't combine with anything. The negative 15 comes down, that wouldn't combine with anything. And that's where you stop. You know, there's no other simplifying to do. There's no like terms to combine, there's nothing else to do. So that's how this works. The next example is the same thing, you know. 4x times 3x, that's 12x squared. And then 4x times negative 2 is negative 8x. And then negative 1 times 3x is negative 3x. And then negative 1 times negative 2 is positive 2. Right? Negative 1 times a negative 2 is a positive 2. And then these two terms combine. 12x squared comes down. These two middle terms combine to be negative 11x and then plus 2. Okay? How about this next example? Let's slow down a little bit. Maybe you pause and try this on your own. But here we go. What comes first? What comes first? X times x to be x squared. You know, x times x is x squared. Okay? Because remember, it's like x to the first times x to the first. You add those powers, technically. All right, what comes next? We have to multiply to here. Okay, like what is that? What is x times 3? Well, that should just be plus 3x. Okay, what comes next? Now we start to distribute the 8, you know. In a way, so again, to kind of recap, we did the firsts, we did the outers, and now it's time to do the inners, you know, but it's really just distributing, you know, the stuff that needs distributed. So what is 8 times x? That is 8x. And then what's the next thing to do? We got to do this distributing, which is the L in FOIL, the lasts. Positive 8 times positive 3 is positive 24. And then are we done, or is there any cleanup we can do? Is there any further simplifying to do? That's right, positive 3x and positive 8x, they make positive 11x. X squared just comes down. Positive 24 just comes down. There's nothing to combine. No like terms with those. Final example. Oh boy. Taking it to one more mini level. Another mini leap forward here. Look at this. This is a binomial enclosed in parentheses times a whole trinomial enclosed in parentheses. Okay? So this is going to be different, just a little bit different from these other examples where this FOIL acronym applies. FOIL won't apply here, but it's just the same kind. So I said this was like different, but it's also very, very, very similar because we're still just distributing. We have not just the negative 3 that's being multiplied to all of this trinomial, but also the 2x. So we just have to distribute both of them all the way through. So we're going to be distributing the 2x, but then we're also going to be distributing the negative 3. Ooh, that's a lot of multiplying. So what happens when we distribute the 2x through that trinomial? So 2x times 1, that should be what? What's 2x times 4x squared? 8x to the what? To the what? To the what? Third power. 2x times x. What is that? What's 2x times x? 2x squared. What's 2x times negative 6? Negative 12x. And now we have to distribute the negative 3. That's actually pretty easy, distributing just a negative 3. Negative 12x squared. Hopefully I don't run out of room. Negative 3 times x is just negative 3x. And then negative 3 times a negative 6 is positive 18. So again, we just distribute the 2x to this second bubble. And then we also distribute the minus 3. Okay? And now, is there any cleanup we can do? Will anything combine with 8x to the third power? Any like terms? Nope. So 8x to the third just drops on down. 2x squared. So in a way, I mean, I don't know if this is your style, but you could almost like now cancel that out. We've already brought that down. How about 2x squared? With the negative 12x squared. Positive 2x squared, negative 12x squared. That makes negative 10x squared, if I'm not mistaken. All right? And then how about this negative 12x? That'll combine with this, negative 12x and a negative 3x. That'll make negative 15x. And then it looks like we have this plus 18. That won't combine with anything. There's no other like terms with just positive 18, a constant. And that's it. Now, the only other thing I want to say right now to kind of, I don't know, to kind of give you some context, to kind of give you a little peek at like the bigger picture and help you understand the bigger picture. You don't need to write this down, this next thing. In fact, I'll even like write it on like a different piece of paper. You know, in a previous lesson, we did something like 3x squared minus x plus 2, and then plus, 5x minus 2. I don't know, whatever. You know what I mean? Problems like this that we did in an earlier section, you can't confuse bubble plus another bubble, or if that plus was a minus, that is different than a bubble times another bubble, okay? In this problem, we had to like do all of this distributing, but in a problem like this that we did in an earlier lesson, the only distributing you might have to do is like just like a positive 1. A positive 1 technically would get distributed. And then here, technically, you could say there's a positive 1 out here that gets distributed. But you're not going to multiply like 3x squared with 5x and 3x squared with negative 2. It's because this is not bubble times bubble. It's like there's a plus sign in between or a minus sign. So you got to be able to differentiate, problems like that just based on looking at them and what's happening. Anyway, that's all, folks. Let me know if you have any questions on the homework. See you next time.